Okay, guys, let's see what we have going on this one. Well, okay, so with this, we're going to be asked to calculate some definite integrals, and we're already given the areas under the curve. Okay, so we know that the definite integral is just accumulated net area. Okay, but there's some properties over here that we're going to use, and so you want to become familiar with these. Make sure and take these down. So I'm going to refer right now to this table with the properties. Okay. So the first two properties are definitional, but given how much we've focused on definite integral being accumulated net area as we go from A to B, I hope that they'll make sense. So our setting is that we're going to have two functions, f and g, be integral functions on an interval that contains x values a, b, and p. Okay. So our first is definitional. The integral from a to a of f of x dx, the definite integral, is 0. Well, we didn't go anywhere. We weren't able to accumulate because our interval had 0 width. So I hope this makes sense, this definition. If we're ever asked for the definite integral from a to a where they're the same number, that value is just 0. Okay. Now let's look at the next one. The definite integral from b to a of f of x dx this is again definitional, so we have to kind of remember this one, is the negative of the integral from a to b of f of x dx. So we can switch our bounds around as long as we put a negative sign in front of our definite integral. Okay, so that's just definitional. Integral from b to a is the negative of the integral from a to b of f of x dx. Next one I think makes a lot of sense. Integral from a to b of f of x plus g of x dx. We can break that down and integrate f of x dx from a to b, and then integrate g of x dx from a to b, add the two of those together. Okay. Let's see the next piece. Okay, the integral from a to b of c times f of x dx. Well, remember what the integral does. It's just accumulating area, right? So if we're multiplying some constant c, every one of those rectangles is just getting c times as big. Well, using the distributive property, right, I can pull that c out front, thinking in those terms. So I'm not formally going to prove this one either, but we have c integral from a to b of c times f of x dx is, we can pull that constant out, it's c times the integral a to b of f of x dx. And this next one, I think, very intuitive, especially based on some exercises we've done. Integral from a to b f of x dx is the same as integral from, let's say, p is between a and b. That's probably how we're going to usually use it. We wouldn't have to be the case, but that's typically how we're going to be using this. We've got some x value p between x values a and b. We can integrate from a to p f of x dx, and then add that to the integral from p to b of f of x dx. We can break it up into pieces if we like. And we were doing a lot of that when we were using our geometric intuition to do our definite integrals. We're kind of already taking advantage of this. Okay. Lastly, if we can, since f is integrable, the absolute value of f is integrable. Okay, and the integral from a to b of absolute value of f of x dx is the sum of the areas, not the sum of the net areas. So what we've got to kind of be sure of here, if there's we learn later, is that when we are working with absolute values, any things that would typically be a negative area, we've got to make sure that we count those as positive if we're working with the absolute value function instead of the original function f of x. Okay, so let's look at a couple questions here from your textbook, and they just want us to use these properties, these 6 properties. The integral from -4 to -4 of g of x dx. Well, again, we didn't go anywhere. We just stayed at -4. There was nothing to accumulate. So this is going to be 0. The next one, integral from 3 to 6 of -5 times f of x dx. Well, if you remember, this constant we can just pull out front, kind of the old distributive idea, right? 3 to 6, we've got -5 as we go from 3 to 6, f of x dx. So now we can just go, let's see, as we go from 3 to 6, that's a -6 is my net area. Got a -5 in front, so this has got to be -5 times -6. This all evaluates to a -6. So this is going to be 30. And then 7 to 3. Well, okay, so now I'm going to, remember, I'm going in reverse. 7 to 3. Well, if I went 3 to 7, remember this is then the negative of, we're used to going left to right, like 3 to 7, f of x dx. I can flip it around and put a little negative sign, right? Well, then this is the negative of, just looking as I go from 3 to 7, it's all this, this -3 net area. So that's going to be, replace this whole thing with a -3. So it's the negative of -3. So it's +3 since we're going reverse, right? So this will be a 3. Hope that helps. Talk with you soon.